Hello students, good morning everyone. Today we are going to discuss the brief introduction of maximum subarray problem under the divide and conquer approach. So let's get started quickly. So everybody wants to maximize their profit in the share market. So this is the famous meme from the Bollywood movie. Can you name the Bollywood movie? And this is the famous meme material like in 25 days your money will be doubled. So these three characters are expecting that after certain number of days they will have a lots and lots of money. So we are going to discuss today the problem description of the maximum subarray, divide and conquer solution, its algorithmic intuitive discussion, time and space complexity analysis, and one problem introduction from previous year question paper. Moving forward, we have seen that these are the popular example in the divide and conquer example, and we will discuss today maximum subarray problem. Okay, so this is the hook for the discussion. We want to maximize our invested money in the share market. So given the price change array of a single stock, this as an input price change array of a single stock, our function should output the maximum contiguous sum, the low index, the day on which we have to invest, and the high index, the day on which we have to take out the money. So formally, we have a given array of integers. Integers can be positive, negative, or zero. We have to find a non-empty contiguous subarray, including AI to AJ. So all the elements from AI to AJ, such that when you sum up the element, this give you maximum. So maximum AK, K from I to J inclusion, and maximize this sum. What are the constraint? Both and I, J range will vary from 0 to n minus 1, where n minus 1 is the size of the array. J has to be greater than equal to I. So these are the constraint. The constant can be divided into two parts. Contiguity, elements must be next to each other. You cannot skip any element. Negative number, there is a special challenge or the edge cases associated with negative number, because the negative number will reset or reduce your net sum. So this is our final goal, maximize the sum of contiguous subarray. So given a input array of integer, your algorithm should output maximum contiguous sum, low index and high index, subject to the constraint I and j ranging from 0 to n minus 1, j is greater than equal to I. Okay, so let us take this array as an input. So can you tell me what will be the maximum sum possible from this array? So if you consider I equal to 0, j equal to 3, that means we are including this subarray. So net sum is 4 plus 5, 1, 4 plus 1, 5, minus 2, 3, and plus minus 3, 0. So net sum 0. This definitely does not look like a maximum sum possible from this array. Another is I equal to 6, j equal to 8. So we are considering this. So net sum equal to 4 plus 1, 5, 5 minus 5, 0, again 0. So this also does not look like a maximum possible sum from this array. So let us take some larger block, say I equal to 5, j equal to 8. So we are considering this. So what will be the net sum? 4 plus 2 plus 1, 7 minus 5, 2. This also does not look like a maximum sum possible. So can you guess the maximum sum possible out of this array? So can you find the correct solution? The correct solution is I equal to 3, j equal to 6. So from here to here, so this 4 plus 2 plus 1, 7 minus 1, 6. So the net sum is 6, low index is 3, high index is 6. So this is the optimal solution. How to find this optimal solution? What are the different approach that we can follow to find the solution of maximum subarray problem? So if we try to find the maximum subarray problem using a brute force method, we need to find all the possible combination of ij that lead to the maximum sum. So how many possible combination will exist for all ij? How if we try to enumerate all possible solutions? Since both I and j can range from 0 to n minus 1, total number of possible combination will be order of n square. So can we do better than the n square? What do you think? So our approach can be classified into three categories. The brute force solution that we have just seen now, to enumerate all possible solution of ij and choose the optimal solution. Another solution is based on the divide and conquer. We are going to break the problem into non-overlapping subproblem. We have to do this recursively until the problem is small enough to solve directly. Likewise, here we are going to divide array into two parts. Optimal solution can be in either of the half, lower half or the higher half, or a array spanning across the middle that will be formed by maximum crossing subarray. Another approach is using the dynamic programming, and the popular name of that algorithm is known as cadence algorithm. But we are going to discuss the divide and conquer solutions. You can explore this on your own for your interview. Moving forward, so divide and conquer approach will be a recursive functions where the maximum subarray a low to high will call the maximum subarray a low to mid, maximum subarray a mid plus 1 to high, maximum crossing subarray a low to high. So this finds the maximum subarray in the lower half. This finds the maximum subarray in the higher half. This function maximum crossing subarray will find the any subarray that spans across the middle. So it must include the middle. It must include the middle plus one element. And we try to stretch as much as possible in this side. We try to stretch as much as possible in this side. So let us see this with the example. Suppose you are given this is small example where the elements are 2, minus 1, 3, minus 4, 5. So what will be the solution for this? So if you are trying to find the maximum subarray in the lower half, so low equal to here 0, high equal to 4. So low plus high by 2, that will be mid, that you are getting 0 to 2. So your lower half becomes this. So what would be the maximum subarray possible from this? 3 plus 2, 5 minus 1, 4. So this will return 4 with a low index 0 and 2. What this function is going to return? The higher half. So this we have to consider only the 5. So this will return 5 and the index 4, 4. What this maximum crossing sum is going to return? So it must include this 3 and we try to extend as much as possible. So 3 plus 2, 5 minus 1, 4. So this will return 4 from this side, and this side 3 must be included, 4 must be included, and 5 also. So 1 from this side. So this is also returning you the same 5. with a low index 0 and 4. So now we have to take maximum of these three. So as a result, you get the maximum sum as a 5, and you got the two possible subset, either the 0, 4 or the 4, 4. So this is the solution of this small example. So let us quickly dive into the code, pseudocode. The maximum subarray problem, A, low, high. We have to first check the base case. This is the base case. The student failed to write the base case in their programming assignment or the theoretical assignment. So if low equal to high, return, it means that array has a single element. So return a low, high. Otherwise, find the mid, low plus high by 2. Call the maximum subarray into the lower half from low to mid. It will return the left sum, left low, left high. Similarly, call the maximum subarray on the higher half, a, mid plus 1, high. It will return right sum, right low, right high. Then the third function, maximum crossing sum array from the low to high. It will find whether there are any subarray that spans across the middle. This we are just comparing the left sum, right sum, and the cross sum. Whichever is greater, we return the corresponding sum and the low and the high value. If left sum is greater than right sum and left sum is greater than cross sum, we return the left sum, left low, left high. Otherwise, if right sum is greater than left sum and right sum is greater than cross sum, we return right sum, right low, right high. Otherwise, we are going to return cross sum, cross low, cross high. These are pretty simple. The core logic is the recursive function and the base case. So this is just a 15 to 16 line of code. Next, we have a maximum crossing subarray. So this logic will be divided into two parts. First, we have to include this mid. We have to try to extend the sum as much as possible in the left direction and mark the boundary using the I. So we'll initialize the left sum as a mid, max left equal to a mid, cur sum equal to 0. We'll start from the mid. For I in the range mid, low minus 1, we'll try to decrease the I. We'll find the cur sum by adding the AI value. If cur sum is greater than left sum, we'll override the left sum equal to cur sum and max left equal to I. Similar procedure we have to do for the right side. So right sum equal to a mid plus 1, max right equal to mid plus 1, cur sum equal to 0. We try to include as much as possible, maximizing the sum in the left side, mark the boundary by j. For j in range mid plus 1 to high, if cur sum equal to, add the current element. If cur sum is greater than right sum, update the right sum to the cur sum, max right equal to j. At last, whatever the sum you get in the left side, that is left sum, and whatever you have got in the right side, add both the thing, because it has to span these two elements. So this side you are getting the left sum, this side you are getting the right sum. This function will return left sum plus right sum, max left, max right. So in total, it will look like this. So approximately 20 lines here and 50 lines earlier. So it is approximately 35 lines of a code, not complex code. We need to understand how these codes work on a certain example using the recursion call graph. So let's quickly see the before that, the time and space complexity analysis. So what would be the recurrence relation for this function? So let Tn be the time complexity to solve maximum subarray problem of size n. Base case will take theta 1. You have to just compare. If low equal to high, you have to return that element. Otherwise, you have to divide the array into two halves. Call the maximum subarray on each of the half. So net cost will be 2tn by 2. For each half, maximum subarray will take tn by 2. You have two such called 2tn by 2. Theta 1 is for base case comparison. Next, you have one more function called maximum crossing sum that will take theta n time. After calculating the result of three functions, you need to compare which one is giving the highest. So this theta 1 for that comparison. As a result, you get Tn equal to theta 1 plus 2Tn by 2 plus theta n plus theta 1, which can be simplified as Tn equal to 2Tn by 2 plus theta n. This is a very simple recurrence relation which can be easily solved either using master theorem or recurrence tree method. Using master theorem, cost at root become equal to Fn, that is equal to order of n, whereas cost at leaf node become n to the power log b base a. Both b and a are the 2, so 2, 2. So it become n. Comparing this, both are same, so it comes under the second case of the master theorem, which will result in order of log n. We are not using any auxiliary space to store any variable, but if we consider the recursion depth, so the space complexity will be order of log n, maximum recursion depth. So this is the time and space complexity analysis of the algorithm. So this is the previous year, one of the previous year paper. Given an array consisting of a number of the following element: 2, minus 5, 6, minus 2, minus 3, 1, 5, minus 6. Find a contiguous non-empty subarray within the array that has maximum sum and return the sum as well as the array element. Implement using the appropriate design paradigm and give the optimized algorithm and derive the space complexity. Try to solve this problem. We'll discuss the detailed solution in the next video. Just to give you a hint, we need to draw a recursive call graph. So first call will be MS, if we abbreviate MS as maximum subarray and MCS as maximum crossing subarray. First call will look like this. So this will recursively call MSA03 because low is 0, high is 7. Low plus high by 2 becomes mid, that is 3. So MSA03 and MSA47. This will be the two recursive call, and the third call maximum crossing subarray A07. So we'll try to complete this recursive call and find the solution. We'll discuss the detailed solution in the upcoming video. The total solution will look something like this. If you have any doubts or questions, query, please share your doubts in the comments. I will try to answer to your query. If you like the video, please share and subscribe. Also, let me know if you want to make me to any video on any particular questions of the algorithm. Thank you, everyone. So this is the brief overview of divide and conquer. This is the generic equation of time complexity, a recurrence relation for the divide and conquer. Thank you, everyone.